So today, I'm just going to demonstrate some .NET projects. That's the plan. And .NET is a very strange thing. .NET is Microsoft's competitor with Java, and it is very similar to Java. The point of both of them is, in principle, you can write platform-independent code. You can write Java code and then use the same source code on multiple operating systems, on Linux, on the Mac, on Windows, on Android, because it doesn't run directly on the operating system. It runs in a Java virtual machine. The problem in practice is that it's a god-awful mess. If you start using Java, it's very frustrating. There are many different versions of the Java runtime, and you often need a different version. You end up with multiple versions installed in your system. It's very frustrating. It seems to kind of defeat the purpose, but .NET accomplishes all of that, including the bugs. As we're going to see, there are many different versions of .NET, and even after you install .NET, you'll run something and say, no, you need a different .NET. Oh, no, you need yet another different .NET. You have to keep putting them on, and they're hard to put on. So, it duplicates the whole experience of Java, except I don't think you can run it on anything except Windows. In principle, I think Microsoft intended to have .NET runtimes, which are what they call their equivalent, on other operating systems, but that never went anywhere. Microsoft has done this many times. They made Silverlight an alternative Flash, but it went nowhere. They made ActiveX, and they made VBScript as a competitor to JavaScript, and all these were just disasters. There was another technology that was more accepted, and they couldn't break in. Just like the Windows Phone. They made a Windows Phone, but it wasn't better or cheaper it wasn't cheaper than an Android, and it wasn't better than an iPhone, so there was no reason for anybody to use it.
I don't even remember.
Well, it was considered a pretty good phone, but there's just no reason for it to exist in a market that already is owned by Android and iPhone. You'd have to have something great that it does, and I thought that would be to join the Windows domain, so it would be the replacement for BlackBerry, but it couldn't join a domain. And I said, well, then who's going to use it? Home users are not going to use it. They'll get either iPhone or Android, and people at work are not going to use it. So anyway, so let's...
Just a precision
Yeah.
terminology. When you say that .NET is competitor of Java, you mean JavaScript?
No, Java.
Java.
Yeah, Java. Yeah, JavaScript is just a scripting runs in a browser, and Microsoft's competitor for that is VBScript, which they've now finally abandoned. But Java, that's right, JavaScript and Java are completely different products, often confused because one of them was named to sound like the other. I forget which way it goes. But Java is a coding language. You write compiled applications, but they're only partly compiled. And we're going to see how .NET does it. .NET is real important to the world of Windows. The real developers use it, especially enterprise-class developers. So you need to learn how to reverse it, and it's very easy to reverse, much easier than native code that's compiled right down to assembly code, as we're going to see. And the same thing, by the way, is true of Java. If you take the mobile device hacking class that I think is coming around next semester, we spend our time taking apart Android apps, and they're written in Java. And Java is similarly very easy to reverse and modify. Yeah, because all right, so let's take a look at .NET. PMA 132 is here. Let me just take a look. That's the first one. So we download this file. It's just a little app I made. It's got one called Challenge 1 and one called PMA 131. And you need some tools, which are pre-installed if you use the machine I made. Otherwise, you can download and install them. And so you have to run this program. Now, when you try to run it, it will probably refuse and say you need to install .NET. So there are various techniques. If you're using Windows 10, you can download this thing. If you're using Windows 11, you go into Windows Features and turn it on. And like I say, you have to get a particular version of .NET for this app to run. And once you've got it running, this thing will run. So I've already done all that on my local virtual machine. And by the way, this project works fine on Windows on ARM. It is supposed to be platform independent. And it is platform independent in that respect. You can run it in Windows on ARM or in Windows on Intel. So that's nice. So anyway, this thing is PMA 132. Here it is. So here's PMA 132. And so I double click that, and it should run and launch it. There we go. All right. And this is going to warn me that it doesn't like it. I'm just going to say run anyway. And this was part of the Flare-On challenge. The people, Mandiant, have had a challenge every year, a CTF, and I take the easy ones and put them in my class. So this is a picture of Bob Ross, and when you decode it, this text turns into garbage, and this turns into a dog, and so you have to figure out how this decoding it and write the script that will decode it. So this is the .NET running. Now, if you want to know what kind of app this is, you can right-click and go to Show More Options and open it with CFF Explorer. And again, Windows is going to gripe, but I run it anyway. All right, and now you can see this is a portable executable 32.NET assembly. So it is 32-bit .NET code. That's what it is, and I had to have the right machine to run 32-bit .NET code, which they call a .NET runtime. All right, so now that I've done that, then I think we just look in ILSpy. Yep, all right. So ILSpy is one of the tools that lets you look inside there, and that's because when .NET compiles, it compiles to something Microsoft calls intermediate language, which is what runs in a .NET runtime. This is, and Java compiles to what it calls bytecode, and that runs in a Java virtual machine. It's exactly analogous. It's partially compiled, not down to the assembly code for the processor, but down to an intermediate language, which runs in a Java virtual machine. That's the idea. So you can examine it with this tool called ILSpy. This is a free tool, seems to work pretty well. So in ILSpy, let me just remove this old stuff so I can put it in again. I'm going to remove. Okay. So even load ILSpy, it loads some stuff that has to do with the .NET in the operating system. It loads this stuff, so you can ignore that. Then you open the thing you want to analyze, which in this case is challenge 1, I think. All right, and once you're in here, now this is going to be just the same with Java. Everything is, it's object-oriented code. So there's a container, and the sub-objects have containers. It's nesting containers. So your challenge is a container out here, and when you expand it, there are various things in here, like resources and such. And then there are forms, and they name part of it X. But here's the form. The form is the part that displays something for the user, like that button you can click. And so down here there's a button called Button Decode. So you can click on it, and it will show you the code. And just like Java, you have the source code, because the intermediate language is easily turned back into source code in C++ or other languages. In fact, you can choose the language. You can choose to examine it in various versions of C++ here. You can also, we're going to use, I think you can also turn it into, you can also turn it into Visual Basic with some programs, but not this one. But we can in fact see the raw IL. Here's the intermediate language. And these commands are very much like assembly code languages. It's very much like assembly code, but it's not. But the point is, when you have this, it has the names of everything, and so you can turn it into C#, and C# is very readable. And so you can see here what it's going to do. It's going to read a file called .secret, which is in the resources, and then it's going to go for each byte in .secret, it's going to do this transformation. So this is the unscramble. It's going to shift it to the right by 4 bits, and then or shift it to the left, ampersand F0. So this is going to keep only the high order 4 bits, and then XOR it with 29. So this is just a simple bit shifting, bit flipping transformation, and that's what we have to do to get it. So what you can do is you can save the secret from here. Here's the secret data. So you save that, and I've already saved it here called dat.secret. And then you can just write code that does what that button does. And you can just write it in Python. In fact, I had a student who wasn't a good Python coder, and what I told her to do, which worked, was if you don't know how to write Python, just copy this into Gemini and say, translate this into Python, and it will just do it. You don't even have to know how to write the Python. This they're calling vibe coding these days. In fact, there's even a job offer that said they need someone with 3 years experience in vibe coding, because obviously the person that wrote it doesn't know what the hell they're talking about. They think vibe is a language. Vibe coding is what they say when you just use an AI to write the code, you just use it without examining it, which is pretty risky, but it's fast. So anyway, I did it with, I wrote my own Python for this, and I gave you the right code. So if you open with Notepad, all right, so here's the code that does it. This reads the secret, and then byte by byte, it just does that transformation. Looks very much the same. Shifts it to the right by 4, left by 4, ampersand 0, 29, and then it prints the text. So that just does that transformation. And so if you run this, you'll get the flag. And so that's pretty simple. And as usual, the first one you can do by just following the steps, and you'll get a flag. And all the answers, since this came from the Flare-On contest, all the answers look like email addresses going to flareon.com. That's the format of their flags. And then I made a second file with a flag. And a third one down here, which is Fun Meme Cat Battle Station. This is also from then. This one here is also .NET, although you're going to have to install a different version of .NET. It'll pop up a box and tell you to install a different .NET runtime. And once you get it, you'll have this object. Now, it really freaks out about this one. I don't know why. It was just part of a CTF. But anyway, that's why we're using a malware analysis machine. So even if it is real malware, I don't care. It's not. But apparently it has something that Microsoft doesn't like.
I never seen this cover.
No, I've never seen it either. And so I run anyway. And there it is, Meme Cat Battle Station. This is a game. Let's see if I can get rid of this, There we are. So it's a game. And so what you have to do is you have to, let's see, I think I have to maximize the window there. And there, you have to put in an arming code here. And it has to be right, or your fire won't have any effect. And you have to find 2 arming codes. So again, since you can see the source code, you just have to look in the source code to find them. And the project gives you an explanation of how to find them. Load Meme Cat Battle Station and drag down here, and you'll find this is the fire button. The first one, the code is right there. The next one, the code is scrambled. And I think this is the one where I said, and again, if you can't read the Python, you don't have to. Take it to an AI and say, what does this Python do? What does this code do? Or rewrite this code in Python, and it'll pretty much just do it for you. It's not that hard. So anyway, then you should be able to get the 2, once you get the right arming codes, you win the game, and then you'll get a flag. So that's what I want to, this is the first one, just so you see what .NET does. All right, let me stop this one.